Suppose you are working on this simple table, categories like temperature and color, city, etc. But your machine learning model doesn't speak hot or blue or any city. It speaks number. All these cities, color, temperature need to be converted into some sort of numbers, and that's where encoding techniques comes into picture. Today we are going to talk 5 different encoding techniques. We'll start with hash encoding, then we'll do Geo Hash Encoding, followed by gray encoding, Bayesian encoding, and binary encoding. First, we have hash encoding. Hash encoding is also known as feature hashing or hashing tree, and it's a smart way to handle data with tons of unique values. Imagine you have thousands of different product names or user IDs. Instead of giving each one unique column, we use a hash function to convert them into numbers. This saves memory, works super fast, and it's perfect for big data or streaming. But it's not perfect. Sometimes two different values get the same hash. That's called a collision. Also, it's not great if you want to understand what each encoded number really means. It's used a lot in text data, recommendation engine, and online learning models. Now, this is how the hash encoding would look like for temperature and color column combined together with 6-digit precision. We'll later go through Python code, GeoHash encoding. This one is designed for locations, latitude and longitude. GeoHash turns these coordinates into a short string of letters and numbers. Nearby places create similar hashes. That means you can quickly find people or services close to each other. But keep in mind, two locations are just on either side of boundary. They might end up with very different hashes. If you want high accuracy, the hash needs to be longer. It's used in apps like food delivery, ride hailing, or location tracking, like restaurants near me. In our example, with this city, latitude, and longitude, you can get GeoHash like this. The nearby coordinates share GeoHash prefix, and that's how we can filter out nearby places. Gray encoding. This is also known as gray code, is a method of encoding binary numbers where only one bit changes at a time between consecutive values. This technique is especially useful because it reduces errors during analog signal transitions. While not commonly used in standard machine learning pipelines, gray encoding is still fascinating and extremely valuable in hardware and sensor applications. What are its benefits? It minimizes errors during bit transitions, and it's ideal for hardware or sensor data processing. But there are downsides. It's not interpretable and isn't widely adopted in traditional feature encoding workflows for machine learning. Use cases: you will find gray encoding in robotics, digital electronics, and some types of genetic algorithms or feature crossings. This is how it will look like if we compare to binary encoding for temperature column. So if you see here, the gray encoding, every time only one bit is changing. Here 0 is becoming 1. In this case 1 is becoming 0. But compared to that, the binary encoding, you can see for these two, both the bits are changed. That's why the key difference between binary and gray encoding. Bayesian encoding. Bayesian encoding is a technique that encodes categories using digits from a custom base. Like it could be binary, base 3, base 4, or so on. Each category is first assigned a number, and then that number is converted into its Bayesian representation. So why use Bayesian encoding? It reduces dimensionality compared to one-hot encoding, offers a compact representation, and performs well when the base or n is chosen wisely. But we need to be careful It doesn't preserve ordinal or semantic relationship between categories, and choosing a base that's too low can confuse machine learning models. Where we see its use, Bayesian encoding is useful in embedded systems and sometimes in genetic algorithms or as part of feature hashing variants. So if you see here for color, first we convert it into integer, and then this integer is converted into base 3. So 0 becomes 0, 0, 1 becomes 0, 1, and 2 becomes 0, 2. So if we have more values, we'll see how the base 3 is converting these values. Binary encoding. Binary encoding is a method for converting categorical variable into binary digits, or by using their ordinal integer representation. Each category is assigned an integer. For example, a equal to 1, b equal to 2, and c equal to 3. So after binary representation, 1 becomes 0, 0, 1, 2 becomes 0, 1, 0, and 3 becomes 0, 1, and so on. Each category is now represented by a fixed length binary vector. So why we use it? It helps to reduce dimensionality. It retains information, works well for high cardinality data, and can improve model performance. But it has got few drawbacks. It may reduce interpretability, risk losing some information, and models can become sensitive to how the encoding is applied. What are the use cases? Binary encoding shines when working with high cardinality categorical features. In tree-based model like LightGBM or XGBoost, it's frequently used, and in environments with limited computing resources, this is very useful. So again, as we have seen earlier, this is how the temperature variable can be converted into binary encoding. So first we assign integer for each unique values for that variable, and then we convert this integer into binary with padding if necessary. So we have covered 5 different techniques, and if we summarize, hash encoding is memory efficient, scalable, but the problem is not interpretable. GeoHash, spatial proximity encoded, and it's useful for location based encoding, but there are issues for border precision. Gray encoding, bitwise stability, seldom used in traditional machine learning algorithms. Bayesian, compact representation, but there is no category relationship. Binary, among all these, most efficient for tree-based model, and sometimes the implicit ordering can give wrong interpretation to model. Now, we have seen all these 5, and naturally we have to decide which one is good for what. So hash encoding is good when there is high cardinality of text or ID features. You should avoid it when you need interpretability. GeoHash, if you need location clustering or spatial data, go for it. But if you need precision near borders, you have to do some more thing on top of it. Gray encoding, go for it for hardware, robotics, or simulations. Avoid it in standard ML workflows. Bayesian, memory constrained systems, and avoid when relationships really matter. Binary, tree-based models is the go-to way of doing encoding. It also makes compact encoding. Avoid it in linear models without preprocessing. Now, let's take a quick look at these 5 methods implementation using some of the Python libraries. So here we are importing pandas and then setting up all these variables, color index, and then loading them into a data frame. So first we are creating the data frame. This is how the data frame would look like. It's exactly same as what we have shown earlier. First we'll start with hash encoding. We'll be creating one function. The input for that function is data frame and columns. In that function, we will be using lambda function and use Python native hash function to convert the columns into hash. The target columns will be converted into hash. We'll be using pandas.apply method that will convert each rows using this lambda function. After that, it will return the encoded data frame. Here, we are applying this method for our original dataset, and we are using temperature and color columns. So let's take a look how the data frame looks like. So this is the native implementation, and you can see hash encoded values. We can have another implementation using hashing encoder from category encoders library. Same like earlier, we'll be creating a function, we'll pass on data frame, columns, and here we'll set default number of components equal to 6, which means it will create 6 columns from the input data after hashing. Apply the hash encoder function on the target columns and then return the value after fit transform. Here we are applying this function for these 2 columns once again, and after we run this, let's see how the combined encoded values are. Yes, you can take a look. These are the 6 columns created and the values after encoding. The one thing important to note here, in this case, we are using both temperature and color together and then combining them for hashing. And that's why it's a combined hashing. Compared to that, in this case, we did separate hashing for each column. Now let's take a look at Geo Hash Encoding. For this, we'll be using GeoHash 2 library. Similar to earlier, we'll be creating one function. We'll pass data frame. The input fields are longitude, latitude, precision. Here we are passing 5 as default value, but you can change at the time of applying the function. Again, the lambda function is used to apply the GeoHash encoding using this GeoHash2.encode and applying for both the rows together, and then return the encoded value. Finally, our original data frame is applied for this function with our target columns, and we get the combined data frame. You can see if we run, this is the GeoHash encoding for these cities. Gray encoding. We are using gray encoder from category encoders. We are creating a function and we are calling the gray encoder. Then again, we are applying this gray encoder for our target columns and our target data frame. Finally, we are concatenating original data frame with encoded values. And this is the combined. So we can see temperature and colors encoded. Next, we'll go through base N encoding. Base N encoder from category encoders library. Again, here we are using another function that we are calling to create this encoding. We'll be passing data frame, columns, and here by default we are setting base equal to 3, but you can change as per your need. So this will convert the columns into base 3 encoding, and then it will return the encoded data frame. Similar to earlier, we'll be applying this function to our data frame and target columns like color and temperature. Here we are using base equal to 3. This is the combined data frame. Let's take a look. So this is the data with base 3 encoding. You can see the values are in the range of 0, 1, and 2. Lastly, we'll have binary encoding. We are using binary encoder from category encoders library. Again, we'll be creating one function. We'll call binary encoder, fit transform, and then we'll return the data frame. This function is then we are using with our data frame and then our 2 columns. Let's take a look how it looks after we apply the binary encoding. So here you can see temperature and colors are binary encoded. That's all for Python coding. Encoding isn't just a pre-processing step. It's where raw data meets intelligent structure. Whether you are working with temperature, color, or coordinates, using the right encoding can make or break your model. I hope walking through this dataset made it easier to visualize how encoding works. Let me know which encoding you would use in your next ML project. Don't forget to like and subscribe for more intuitive ML walkthroughs.